So, today we're going to continue our look at algebra, and we're going to look at something called linear graphs. But before we do that, I just want to recap and talk a little bit about what we did last time. Remember, last time we introduced the idea of the Cartesian plane, which is simply two number lines that meet at what? At right angles, yes. And they both cross where they equal 0, which is called the origin. Excellent. And, oops, I can't spell. Now, what is the horizontal number line usually called? It's not coming up there. Okay, so I need to unfreeze that. Thank you. There you go. What is the horizontal one called? The x-axis, yes. And the vertical one? The y-axis. Excellent. Okay? So if it has two number lines, that means it has to have how many values? Two values. We have to have an x value and a y value. And this is something called an ordered what? Pair. Excellent. Love the way y'all say it so much more beautifully than I do. Pair. You know, American accent just doesn't do it. All right. Also known as coordinates. And that's why this is also known as sometimes as the rectangular coordinate system. So later you might see it as that. Now remember that the x tells you how far to move, either right or what? Right or left. Be careful. Right or left, right? Positive means to the right. Negative means to the left. Your y value tells you how far to move, either what? Up or down. Good. Positive means go what? Up. Negative means down. Excellent. Sound good? And remember, if you can count, you can graph. Where does everything start when you're graphing? At the origin. So if I was going to graph 1, -3, that means starting at the origin, I would go what? To the right 1. Good. And then what? Down 3. So that would put me about right there. And remember, if we're just plotting points, it's important to label them so that you know that's the point you have. Yeah? What if I gave you a point and you had to find the values? How could you do that?
Just count out the lines.
Exactly, just count out the lines. So and I didn't have any lines on here, but let's pretend. So this one, again, starting at the origin, I would go not right, but what? Left 3, and then up what? Up 2, right? According to my little numbers here. So that would mean left 3, so -3, up 2, so +2.
Yep.
Looks good? If you can count, you can graph. And if you can't count, get a friend. Okay, now you can all count. Come on. So, just make sure you always remember, though, it's always which letter first? X, and the Y is always the second one, yeah? And they have to be done in that order. Now, you don't always have to have those same letters. You can also use other letters, too. Say we were talking about time and height, right? I could use T and H. If you're talking about specific items, then you can use, just like we did before, we could make them make sense, yeah? You can also have things given to you in a chart form. So that's 1, 5, 2, 7, 3, 9. And the numbers go together, don't they? So 1 and 5 would go together to make an ordered pair. So you can also have them in chart form, and that's really important. Can I make my chart go up and down? You bet. It makes no difference which direction. Right? Okay, so you can also plot points from a chart, not just as ordered pairs. Sound familiar? Okay. Anybody get that homework done? Some of you have done a little bit, but some of you didn't. Some of you didn't sign in. So yeah, this one. Hold on a minute. Okay, guys. All right, let's see. So, again, I don't make the jokes. My jokes are much cornier. So, are you ready to do some plotting?
Yeah.
Here we go. So, plotting. Plotting means that you're drawing points on a graph. So what we were doing with those ordered pairs yesterday, where we had our x's and our y's, right? And we were translating to those to points on a graph, that's plotting. Plotting a point. Okay? Makes sense? So, and plotting a point is a useful way of displaying relationships and patterns. Now, because if we think about it, when we were looking at those charts were patterns, right? And patterns, we were saying, were numbers that had a relationship. So we were adding 2, multiplying by 5, whatever. And so using a graph or a picture is a lot easier sometimes to find a pattern than just seeing a random group of numbers, right? If I describe something to you, or you could see a picture of it, which one of those would you get faster? The picture. Pictures, we think in pictures, many of us. And so it makes sense for us to see things in pictures. Well, a graph is simply a picture of a mathematical sentence or a mathematical idea. And so that's what graphs are so important. They're great. They make great at displaying things. So, the previous lessons, we learned how to write things in tables. So here's a table. N stands for the number of the term it is, right? So the first term, second term, third, etc. And T is the actual number value, right? So 7, 10, 13. So what do you know about these as far as, say it was a 3 and a 13? Can those numbers in this particular pattern ever be separated? No. The third number of this particular pattern must be 13, right? Okay. So we could make an ordered pair out of that by taking the N and the T instead of X and Y. So what would the ordered pair be then for this particular? 3, comma, 13, enclosed in a bracket, exactly. So we can take things straight from a chart and turn them into ordered pairs. Now notice that we didn't use X and Y, but we don't have to, right? Because in this case, we had descriptive variables, descriptive letters telling us what to do. So because they represent pieces of a pattern, we say that they have a relationship. The two numbers have a relationship. Think about relationship. That means that you're joined together some way. You have something in common. Yeah? Now, can you just name any two random numbers and they have a relationship? No, wait a minute. You just did a pattern though, 2, 4, 6, right? So if they have a pattern, they have a relationship. But if they don't have a pattern,
they're all divisible by 1.
Okay, but numbers have to have a pattern in order to be considered to have a relationship. Good. So that's why we looked at patterns first. Now, so imagine two gears that are linked, right? What happens? As one turns, what happens to the other? Well, the other one's turned by the first one, right? Yeah? So they link together, and so they make things happen. So if I have the third number of a pattern, okay, it's linked to the whatever value that is. And then if I progress it, in other words, turn the gear, I am making new numbers using the same pattern, right? But it's the same pattern, but we're just continually getting new values. Excellent. So you can think of it like this. If you change N, you also change what? T. And that's huge. Does it make sense to you? If you change one, then it also changes the other one. That is a very, very important idea in algebra. Okay? So, keep that in mind. You're doing really big work if you do that. So how can we plot a relationship? We'll do it using the Cartesian plane. But notice they don't give us the whole thing here. Instead, what they've done is they've given us arrows to represent everything beyond the origin. So what's happened is they've given us all the positive numbers going to the right and all the positive numbers going up, and they've ignored everything else. So that tells us that our relationship isn't going to have any negative numbers in it. Well, that happens a lot in life. Can you go backward in time? So time can never be negative, right? Okay. Can you, can you have, I can't get past time for some reason. So think of some things that can't be negative. If you're having costs for a business, is somebody all of a sudden going to pay you to use something? No. So your costs are going to always be positive. They're always going to be in that positive range. So people's age, right? Can't be negative, can it? You're not going to grow younger. Darn it. Okay? So some things are only necessary to see that one section of the graph where everything is positive. Okay? Yes?
Is this saying like you can get just one section of just negative?
You could certainly do that. You don't want it to happen unless you're talking about, something. Yeah, let's not talk about that. But even then, even after you die, doesn't time still keep going on positively? Yeah, just not for you. So most stuff happens in this one area, but that doesn't mean it has to be. Okay? And so if all the things in these patterns have to be all positive in order to land there. So look at what they did. They relabeled the axes N and T. So instead of X, they used what letter?
T.
Instead of X. They used N. Instead of Y, they used T. So that tells me that the N always comes where? First, and the T comes second. Excellent. Good. So here we go. We have a table of numbers, and what we want to do is just plot those numbers in our Cartesian plane. Okay? So, for some reason they've gotten them so far apart that you can't plot them and see them. So let's just use their plottings. So if you see the first number that they give you on that chart, sorry, I don't like that, is they give you 1, 7. And if you look at the graph, that means they went to the right 1 and then up what? 7. And you see the dot, right? So you can use different values than simply X's and Y's. So now what they want you to do is they want you to plot them on the table. And again, we're not going to take the time for everybody to do this independently. We're just going to plot them on this table. So, and I'm just going to use my cheating card. So it's 1, 1, right? So that means to the right 1 and up 1. So right there. Yeah? What's the next values? It was 2, 2. So to the right 2 and up 2. Then 3, 3. Then 4, 4. Then 5, 5. And what do you notice about those numbers? About those dots?
They're like doing the same thing, so they're all going up in one line.
Yeah, they're going up in a straight line, aren't they? So if you look at this, guys, I could draw a straight line all the way through them, right? Well, can I also assume then that since that's the pattern, it's going to do that forever? You bet. If it's a pattern and we've established the pattern, we can then assume that it's going to continue to do that same thing over and over and over again. Right? Patterns don't typically, these are patterns, so they cannot change. They're fixed. And so they can give us a straight line, which is why these are called linear. Linear simply means a straight line. Oops. So if I say linear, you think straight line. Can it be straight up and down? Sure, it's just a line. Can it be horizontal? Yep. Can it go down? Sure. Just as long as it stays in a what? Straight line. Okay? And no wiggles. So many things happen in straight lines, but not all. Okay? So we'll talk about that a little bit as we look at some of these too. Okay? All right, so that's part of your homework, so let's get out of that because I don't want to be doing your homework. I want y'all to do that. So let's go to the next section. So here's a table which represents a pattern, and they plotted the points on the Cartesian plane. Do you notice that the dots all line up in a straight line? Yeah. That means this is a linear pattern. Linear pattern just means a pattern that if you plot it makes a what? A straight line, right? Okay, not just a line, because not all lines have to be straight, do they? Okay, you don't have curved lines, a straight line. Good. Okay. Now, look at the next one. Notice how all the points line up and can be connected with a straight line? So that makes it a linear pattern. Makes perfect sense, right? You're going to learn that mathematicians are lazy. We don't do anything we don't have to do, and we always name stuff by just what it looks like. Okay? So, now look at the next one. No math class is complete without a cat. All right? So, we're going to connect. Can we always connect the dots to make a straight line? No. And that doesn't mean that they don't line up to make a straight line, but the context may not make any sense. So let me show you what I mean here. Okay? Here we go. If we draw a graph with the dots connected, that means every point on the line is part of the graph. So, if I drew a line on this particular one connecting these, it makes a straight line, doesn't it? I'm perfectly happy with the fact that it makes a straight line. But what is it that we are measuring here? Okay? So that means everywhere on this line, let me erase it so I can draw a better line. That means every point on that line should represent a number of kittens. So what if I'm right here in the middle of those lines? Am I on a 1 or a 2 or a 3 if I'm in the middle? No, if you end up in the middle of one of those boxes, that means it's a fraction, right? Because only if you land right on the points is that going to be a whole number. So, when's the last time you saw 3/4 of a cat? So, no, okay. So, all right, when's the last time you saw 3/4 of a live cat then? How's that?
Oh.
Yeah, never, right? It doesn't work that way. So some objects are not linear because you can't have pieces of them. So what if I was doing the number of people? Can you have pieces of people?
Well, you can do pieces of worms.
Okay, no. All right, I said some. I know there are exceptions for every rule, right? But, okay, sure. So what if I was measuring time, however? Does it have to always be 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock? Can't you have 3:05 and everything in between? So can that be a linear relationship? Can you draw a straight line representing time? Sure, because time can be broken into tiny, 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 tiny pieces. Seconds, milliseconds, right? So for any pieces. So sometimes the context will only allow you to get ... instead of a straight line. Okay? So, okay. So think of something. Can you have a half a house?
Yes. You can.
Okay.
House.
Would you build half a house?
No. Yeah, if you're tired and you just can't finish, or if you want to, you can be in the middle of building a house.
Okay. Can you drive your math instructor half crazy? Yes. It's working.
If you want to build like a lean,
don't get crazy.
You can build half
I
a
mean,
house.
thinking about it, when is the last time you were walking down the street and you saw family living in a house where most of it was missing? Not likely. Okay? So be serious here. Be serious here with me, guys. Okay? Okay? Can you wear half a blazer to school and not get in trouble? No. Okay, how's that? Haha. You can't argue with that one, can you? Okay. Thanks.
You can just say you lost half.
You can wear half.
Okay.
You can just say you lost half your blazer.
You guys. You guys think, I like your out-of-the-box thinking, but that's not half a blazer, that's half on. Okay, so here we go. So, things that would die if you cut them in pieces should probably not be cut in pieces, right? So, that means you can't draw a straight line. Okay? Can you watch an entire video, the whole thing, and then say you've watched part of it? Nope, you've watched the entire thing. So that's a number. Now we're not ever going to lie, right? So that's an entire number. Okay? So be careful about the context. Now look at this one. Okay? So you see that here you can't do 2.5 or 7.5 kittens, can you? Can't have part of a kitten. All right. Now, the time spent studying, watching cat videos. Can the time you spend watching the cat videos vary? Yes. Could it be half an hour? Yep. Could it be 1 hour and 33 seconds?
Yes.
Sure. It can be an infinite amount of time. So could time be linear, a straight line?
Yes.
You bet. So do you see the difference there? So be careful of the context. All right? Good. How about your grades? Could you, technically, now if you weren't just given whole number grades, but could you get partial credit on something? Sure you could. It's possible. Sure.
A-.
Okay. So could that be a line?
Yes.
Absolutely. Good. All right. Time spent studying. So time definitely could be. Excellent. Right? So if it's appropriate, then you can draw a line to represent the data. If it's not appropriate, then you can only have dots. Now, they can still line up in a straight line, but you can't connect them with a line. Does that make sense? I hope. Good. Okay. All right. Then let's go, because that's part of your homework. I'm not doing your homework for you. Instead, y'all are going to do that. We're back to... Yeah. Okay. So just think about, is it objects you can do? So, all right, here we go. So are you feeling comfortable plotting graphs?
No.
Can you count? Do you know when it's appropriate to draw a line and when it's not appropriate to draw a line? Yeah. If you don't get too carried away, you're going to be fine. So here we go. Let's look at this one then. What do you think that is? Sion? This name? S-I-O-N-E. Do you think that's Sion? I don't know. Observes that there's a relationship between the number of stoats in the bush near his home and the number of pukiko. He plots the relationship in the graph below. Right? So he's plotted it. And so let's, first of all, identify the pieces of the graph. What is he using as his x-axis? What label does he give his x-axis? The number of stoats. So the bottom number, that axis represents the number of stoats. Now notice that he's measuring stoats, so he's only using positives, right? Because there's not going to be a negative number of them, is there? Then the y-axis, what's his measure for that?
Number of pukeko.
The number of pukeko, right? Okay, good. And so and again, that can't be negative, can it? The fewest you can have is what? None, which is 0, right? You can't have -2 of them, though. So do you see the reason why the graph only has that one section where everything's positive? And if you look at the dots there, that each one of those has a relationship. And we're going to look at answer some questions about this graph based on that. So look at the next thing. They give us what we want to do is we need to write all the points in the graph in this table. Right? So first of all, draw and label the table. Since we know that x is the number of stoats, where do we need to put that in the table? Number of stoats. So it's going to be the top line, right? Because the top line is our x's, the bottom line is the what? Y's, right? Remember when we were making these before. And so the number of Pukeko is going to be the y values. Do you think that's important? Absolutely. It must be done in a specific order because they are called even ordered pairs, right? So they can't be out of order or else you get the wrong points. Okay? So there's what our graph looks like, our chart looks like. Now what we're going to do is we're going to take the numbers from the graph to fill in the gaps, the gaps in the thing. So here we go. So here's our graph. That's where we're going to get our numbers, and we're going to put them into the boxes. Oops, sorry. Okay. And they've started for us by putting in the first one. Now, we read graphs just like you're reading words on a page. So that means from the left to the right. Not the top to the bottom, but from the left to the right. Okay? So, where is the first dot if you're reading it from left to right?
0, 13.
Yeah, that dot right there, okay? And so we need a value for it. And so if I'm on this line, how far right or left did I go? None. So that means 0, right? But I did go up. I went up how many? 13. So that's the ordered pair 0, 13. So if I was putting that into my chart, it would be 0 in the top, 13 in the bottom, right? I'm just going to redraw the chart since you can't see at the bottom. Now, look at the next one. It's right here. That means we went right what?
1.
Right 1 and then up what? 10. So that's 1, 10. Look at the next one. What's that? 2, 7. Excellent. Okay. And then finally? 3, 4. And then finally? 4, 1. Make sense? So we're just creating a chart. Last time we started with a chart, we made a graph. This time we started with the graph and we can make a chart. You need to be able to go back and forth between those things. Okay? All right. So you'll see they did their chart and it ended up looking exactly like ours. Yeah? All right. And then you could extend that as you go. Oops, I'm sorry. Now, this isn't part of what you were supposed to be doing, but we're going to do a little problem solving here. Okay? What do you notice about this? As the number of stoats increased, 0, 1, 2, 3, 4, what's happening?
Number of stoats increased, number of Pukeko going down by 3.
Right. As the number of stoats increased, the number of Pukeko are going down, and they're going down by 3. Why do you think that's so? What happens? There you go, right? The predators are eating the birds, and so there are going to be fewer birds if you have more predators. Does that make perfect sense? Okay. What if you were answering a question and your numbers went the other way, and it said as the number of stoats increased, so did the number of birds? What could you conclude?
That they're both breeding by themselves.
Okay. Well, what can you conclude about your data?
Try and eat birds.
Probably your data is bad. Yeah. Okay? It's got to make sense, in other words, right? Now, that could happen. I mean, those birds could be just laying eggs like crazy and, right? Bye. Okay? Because think about it. You get a lot more cats, a lot more dogs, a lot more stoats, but do you see any less sparrows or pigeons? Those things are everywhere, aren't they? So it doesn't affect every bird or every population. Okay. All right. So look at this one. Tianyun, I don't know. You know, whatever happened to Sam and Mary? Tianyun, you think that's a way to say that? Y'all got to help me out. Y'all are much more international than I am. Has a new job where her pay is related to how long she works. Now that makes sense, right? Most people are paid by the hour. A lot of jobs are paid by the hour. But a lot of jobs are paid by how long you work, right? Some jobs are paid by how much you do. But so what do you expect to happen? As the more hours that she works, then what do you think?
I just got a question.
Sure.
The reason why the line is there, is that because it doesn't have to be a whole number?
Exactly, because think about it. Can you make $10? Can you make $8.95? Can you make, so you can make any amount of money, right? And can you work less than an hour? Less than a whole hour? More than a whole hour? Right, so this one can be measured in parts, so this one can be measured with a line. While ago, we use lines to represent what the other thing? Nope, you can't have part of a stoat or part of a bird, right? There you go. Excellent question, thank you. So what do you think's happening here? The longer she works, what happens? The more money she's going to get, right? Okay, so notice that this line, right? This line is going up because the bottom is how many hours she's working, and the more you work, the more money you're going to make, right? Now, a while ago when we were looking at the stoats versus birds, the more stoats we had, what? The fewer birds, so that means the line was going down, right? Okay? In other words, having stoats was a negative effect. Bad, wasn't it? So that made the numbers go down. But working more makes your income go what? Up. Excellent. Good job. Y'all are doing great. Okay? All right. So you see that at just as we said, the more she works, the more she's going to earn. Excellent. Okay? And it doesn't matter, and just like you pointed out, it doesn't matter if it's a whole hour or if it's part of an hour. She'll still make more money, right? She'll make money on those. So that can be done with just letters. Now, anybody know what this plant is?
A flower. A daisy.
I don't know what it is either.
A lotus.
Some kind of flower. Some kind of flower. Okay? All right. So, what you're going to be doing in this homework is you're going to be plotting points. And, guys, focus. You're going to be plotting points, and when it's appropriate, you will connect those points with a line. Okay? And then you're going to be reading information from them. See if you can read from the chart. From the graph and make the chart, and from the chart to make the graph. How's it sound? Pretty good? Okay. Then let me